many ways to simplify the results. And since we have already obtained the results, and we can exploit it here. And now we want to take an inverse Fourier transform to it. So then we should call I Fourier. Sorry. Yeah. Sorry, I made a mistake here. It should be absolute value of X omega. I made a mistake here.
No, shouldn't, I think it's right.
Not A, it should be omega. I made a mistake there.
Then
A should be positive. A itself is positive. So I made a mistake. The final result should be this one.
And then, what about, how do you get the positive one? By e to the a omega over a. No, the one below. How do you get that one? From that equation?
No, from the result, actually. Let's recall the result. If omega is smaller than 0,
when you summarize it,
okay,
how are you able to go back to the positive one? From that general one, how can you go to that one? Because, yeah, how can you go there?
If omega is negative,
then it's to the bad equation. So, you cannot have absolute value.
oh, that's okay. If it is negative, then the absolute value should be minus omega. For instance, if it is minus 5.
Oh, yeah, you're right.
Well, that's okay. If you, for engineering students or researchers, it might be better to give examples in numbers. Okay. So if we take the inverse Laplace transform to the simplified function I obtained earlier, then you can get the result back. So you can easily find the result back. However, the variables might be different. Default variables might be different. And for this function, if we take the Fourier transform, then we may have deeply more complicated result. And in this result, we will see that we have 3 Heaviside functions. 1, 2, and 3 Heaviside functions. So we have to simplify them manually. So we have 1 is omega plus 2a, omega minus 2a. So we have to find the several points. So 2a minus 2a. 2a, 0, 2a minus 2a. We have to consider simplification of the original function over the 4 intervals. And finally, we should get unified result. And you'll not explain it too much. So the final simplified result could be something like, oh, you can just forget about this term, 0 term. Consider the absolute value is larger than 2a or smaller than 2a, that's enough. You can have the simplified result. Because in this part, they have the transform, value of transform 0. So, sorry, in these 2 parts, we have transform 0. And we can unify the result. This result and these intervals. You can try it later on if you are interested in this topic. You can try to simplify it manually. And there is another example. If you look up the mathematics table or the manual of mathematics, you will find that there is a Fourier transform to this function. However, if you try to solve it using Fourier function, then you may find that you cannot obtain the result. The same command will be returned, which means that Fourier transform cannot be evaluated for this function. And if you are trying to solve them by integration method, you may also find a similar thing, which reminds us that not all the Fourier transforms, Fourier transforms to some of the functions may exist in mathematical handbooks, but you cannot solve the problem in Matlab properly. So in this case, we must rely on numerical ways to calculate Fourier transform for certain functions. I think too much about the topic, and we must stop here. Okay? It might be too much. Okay, class is over. Any questions?